Welcome back to another video lesson. In today's video, we tackle 7.3 and 7.5. We're going to be seeing equations that have subtraction and division in them. The table of contents that I need you to fill out is page 79. It's going to be solving algebraic expressions, but I want you to add specifically the symbol for subtraction and the symbol for division so that you know that those are the two operations that we're going to be dealing with today. Our hands-on equation kit did not deal with any equations with these two operations. So this is going to be applying what I taught you in the last video to new operations. We're going to start with some humor just like the last time. Why can't x just be x? Why does it always have to equal something? And my math teacher keeps asking me questions. You'd think she'd know all that stuff by now. Your note sheet is just a small one like on the previous video. All you need to do is glue it at the top of page 79, and then the rest of that page is going to be front and back doing examples like yesterday. We are solving algebraic equations, but like I said, involving subtraction and division. The big idea today is that subtraction has an inverse operation just like addition did. And the opposite operation for subtraction is addition. So in the last video, we used subtraction to get rid of addition. We're going to flip it now. We have subtraction in our equation and we need to get rid of it somehow. We have to use the inverse operation, which is addition. Go ahead and put a plus sign by that. For division, you might already be figuring this out. We're going to need to get rid of whatever is being divided in the equation. To do that, we're going to use the opposite operation, which is multiplication. That is the inverse operation. Go ahead and make a multiplication symbol that we're using in algebra, specifically that dot is what we're going to need to use. The goal again, same as before. You have to get all of the variables on one side and all of the constants on the other side. At the end of the day, you still want x to equal something. I know there's a little box underneath. Again, just like yesterday, I'm going to hold off on that until we get to division. So I'm going to start some subtraction problems right on the bottom. Again, I'm getting these from our packet that we've been working through. The back of it has some extra practice. Yesterday we were on lesson 2 and lesson 4. Today we're going to be getting our examples from the extra practice sheet from lesson 3 and lesson 5. So I'm on lesson 3 right now, getting these examples to start. So example 1 from that sheet, I'm going to put in my notebook, example 1, and I'm going to copy down the equation. Something minus 7 is 2. I know, again, you could figure this out mentally because of your number sense, and that's great. However, I'm going to show you the algebraic steps that you need to show in order to solve it, getting you ready for algebra as you move on into middle school and high school. So, just like last time, we have two sides of the equation. Whatever we do to the left, we have to do to the right. I want to get this y alone by itself so that y equals a number. But I have this operation going on. To get rid of the subtraction of a 7, I have to add the same value. So I'm going to add 7. So right below, I'm going to add 7 on the left and then add 7 on the right. This, if you are in debt $7 and then you pay back that debt, you have nothing. So that's why I'm going to draw a big 0 and cross it out. It goes away. Subtracting a 7 and adding a 7 cancel each other out. And on the left, we're just left with y. I just have to add 2 and 7, and I get y equals 9 as my answer. I do have to perform the check. So I'm going to write the word check and the original equation. I'm going to pluck and plop, and 9 minus 7 is 2. So example 2, still on the bottom of that note sheet, just using up that notebook paper. Example 2 from our sheet is a minus 10 equals 22. Notice the A is still on the left. I'm going to need to get that by itself. In order to do that, I'm going to add 10, thus getting rid of it on the left, but I have to do the same thing on the right. I'm left with an A, and when I add, I have 32. So A equals 32 is our answer for example 2, and now let's do a check. We're going to copy the original equation down. We're going to pluck and plop 32 into the equation, and then I'm going to solve. 32 minus 10 is 22, and I'm done. Now I'd like you to try 3 more of your own. So I want you to pick from this sheet any 3 that you would like to try just with the subtraction. Here I have my 3 examples. I wanted specifically to show you this one, number 19, from that sheet because the variable's on the right. And I just wanted to show you what that looks like. It's the same steps, but we're going to add 7 to get rid of it on the left, and we have to do that same. We want to add 7 to get rid of it on the right-hand side, and then do the same on the left-hand side. So we end up having 25 equals Q. It does not matter the order. I know we're used to saying the variable equals something, but you can switch it around and say that 25 equals Q. That's not a problem. And we have our checks. Make sure you've done 3 of them. This was another one I picked because the variable was on the right-hand side. And we ended up getting 10 equals X. But make sure your 3 have a check and that you have solved the variable by showing the addition to both sides. Now I'm going back up to that note sheet because I want to specifically talk about this before we try division equations. Options. You have a couple of ways that you could solve the division equations. Option 1, you can multiply each side by the denominator. I'm going to show you that way. Also, option 2, you can use cross multiplication. If you remember, we've done that in the past with fractions. And if we have 2 fractions equal to each other, we can multiply the diagonals, the denominator and the numerator, the denominator and the numerator. We've done this when we're comparing fractions as well. This can also work here. So I'm going to show you both ways and then give you some to try. So just a reminder, I'm now flipping in my packet to lesson 5. It says lesson 5, extra practice at the top. That's where I'm getting these examples from. So in my notebook, I'm actually going to do my division ones on the back of page 79. So here's my division work, and we're just going to do 3 examples, and then you're going to do 3. So example 1 from our sheet is 6 equals t divided by 3. Now I wrote it specifically horizontally. You're going to maybe see that, but I want you to write it in a fraction form. It's going to make solving a lot easier. This is actually the form on your sheet, so you can just copy that as well. But I wanted to let you know that when you see a variable dividing by a number, the variable is on the numerator spot. So I'm going to show you the option 1, multiplying by the denominator. The t is connected with this 3 with division. In order to break it off and get rid of that division of a 3, we need to use the inverse operation, which is multiplication. If I were to break this up, I could have t, whatever number, over 1, and then I could multiply it by the fraction 1/3. These 2 things are the same. If you remember the inverse property, it says that you can get a 1 if you multiply this fraction by its reciprocal, and that ends up being 3 over 1. If we were to take this that I'm boxing and multiply it, it would be 1 times 3, which is 3, and 3 times 1, which is 3. This is just 1 whole. That's why what I'm going to do up here is going to work. I'm going to take the denominator, whatever it is, I'm going to multiply it by this, and I will get rid of the denominator because it turns into 1. So let me show you how that's going to work. I'll leave this here, but this is my thoughts, and I'm just going to rewrite this over here so you can see it. So I'm dividing by 3. I want to get rid of it. I have to multiply it by the denominator. Technically, I'm multiplying it by 3 over 1. When I do that, this becomes a 1. And anything times 1 is itself. And now I have a t. That's what I wanted. I wanted to get rid of this division. How am I going to do it? By multiplying by the denominator. But if I multiply by the denominator on the right, I have to do the same thing on the left. So I'm going to multiply by 3 over 1. The good thing over here, they're whole numbers. So 3 times 6 gives me my answer over here. My check is just going to be 6 equals t divided by 3. Then I'm going to pluck and plop. 6 equals 18 divided by 3, and 6 equals 6. That's how to multiply with the denominator. Next, I'm going to do example 2, showing you the other option you have. I have 11 equals a divided by 5. I'm going to put the 11 over 1, because now I have 2 fractions that are equal to each other. Now I can do that cross multiplication trick. I'm going to start at the 1 and go up to the a, and I'm going to multiply, because that's the inverse operation I need to use. That's going to be equal to the 5 times the 11. Now I just have to simplify this a little bit so that I have 1a equaling 55. Anything times 1 is itself, and now I have one variable equaling a number. The check, you're just going to copy the original equation down, pluck and plop. 55 divided by 5 is 11, and it checks out. So that's how you use cross multiplication. I'm going to show you one more. I'm going to go back to that multiplying by the denominator way. Example 3 from our worksheet has 7 being equal to r divided by 4. All I need to do for this multiply by denominator to work is literally look at the denominator, it's a 4, and multiply both sides by 4. That's it. That's the only work you need to show. 4 divided by 4, that is a 1. When I slash them, I'm actually making a 1, reminding you that 1 times r is going to be just r, and 4 times 7 is 28. So really that's the only work you need to show. The 4 and the 4 being multiplied on both sides, this canceling each other out, and then you multiply the other side. Let's do the check for this one. 7 equals something divided by 4. 7 equals 28 divided by 4, and 7 equals 7. Now I'd like you to try 3 more on this page. I want you to do option 1 for at least one of them, option 2 for at least the second one, and then you have your choice of which way to do it for the third one. So I want you to practice both, and then you have the option to do it with the third one. Okay, here I have my 3 examples. You should have done any 3 that you wish, but I'm wanting you to practice multiplying by the denominator, cross multiplication, and then you have the option for the third one. Here I did number 7, and I multiplied each side by 3, giving me a k is equal to 21, and then I checked it. Notice I chose just for space purposes to do this. That's fine as well with the horizontal way of checking. For number 8, I chose to do the cross multiplication way. Again, I'm looking for you to circle what you're multiplying. So in the actual problem, you need to do that circling, and then you're showing that multiplication, and p in this case is going to equal 120, and I checked it. The one I did want to point out is that sometimes you're going to see decimals as well. That's why I purposely picked 17. I chose to multiply each side by the denominator, so you see this being canceled out, the 6 being divided by the 6 is 1, so now we have a z. Over here, we're multiplying the decimal by 6. I did that up here, it's 9. When I check, I actually have to make sure that the math works. So I literally divided over here 9 by 6, and I got 1 3/6, which is the same as 1 1/2. Hopefully you've enjoyed working with hands-on equations, and these 2 videos will be a step in the right direction, going away from hands-on and just solving algebra equations with pencil and paper. We'll practice subtraction and division again in class. However, algebra class is important to you later in life because there's going to be a test actually this week, not 6 weeks from now. I look forward to seeing you then. Have a great night.